So in this video I am going to solve all the examples of this chapter elasticity. So in this question it is given this question. So we know stress is equal to force per unit area. So area in this case will be pi r square. Here the force is given to be 100 kilonewton, that is 10 kilonewton. So it will be 10 to the power 3 since it is kilonewton. So 10 to the power 3 newton. So divided by pi r square, value of pi is 3.14 multiplied with r square, that is having a radius of 10 millimeter. The wire is having radius of 10 millimeter. So if we convert 10 millimeter to meter, then if we convert millimeter to centimeter, then it will be 1 centimeter, and 1 centimeter if we convert into meter, then we will have to divide it by 100. So it will be 10 to the power minus 2 meter, and we need to square it. So pi r square, so we need to square it. So it will be 1 by 100 square, that is 10 to the power minus 2 square. And calculating this, we will get the stress, value for stress. So we have found out stress, that is force per unit area. So this is this value of stress. Now we are going to find the elongation. For finding the elongation, we know Young's modulus is equal to stress by strain, or we can write stress to be equal to force per unit area, and strain we know del L by L. So this is the same value for Young's modulus. So cross multiplying, we get the value of del L to be equal to force per unit area multiplied with length divided by the Young's modulus. So placing this value, we have already calculated the value of stress. So force per unit area is the stress. So this is the value of stress multiplied with the length, and the length of the wire is given to be 1 meter. So we are multiplying it 1 meter divided by the Young's modulus. So here the Young's modulus value is given. So this is the value of Young's modulus. Calculating this, we find out the elongation. Now we need to find out the strain of this question. So for finding out the strain, we need to write del L by L. We need to find out del L by L. So del L by L is the strain. So we have already found out this value to be 1.59 into 10 power minus 3 meter. So this will be divided by 1 meter, that is the length of the steel rod, that is 1 meter. So dividing this with 1 meter, we will obtain 1.59359 into 10 to the power minus 3. So by doing this, we will be able to solve this first question. Next, for solving this question, a copper wire of length 2.2 meter and steel wire of length 1.6 meter, both of diameter 3 millimeter, are connected end to end. When stressed by a rod load, the net elongation is found to be 0.70 millimeter. So we need to find out the load that is applied on it. So for finding the Young modulus of the copper wire and the steel wire, we are trying to find the Young modulus of copper wire and the Young modulus of steel wire. So it will be stress by strain. So stress we have force per unit area, and strain we have del L by L. So it is for the copper wire, so we are writing for C, and for the steel wire we are writing S. So this is the Young modulus of the steel wire. So we have force per unit area is equal to, we can cross multiply these two terms, so we are writing this. Similarly, we can write this also equal to force per unit area is equal to YS multiplied by del S by LS. We are trying to find out this force per unit area because force per unit area set up on both of these wires are same. As because these two wires have the same radius, it is given that they will have the same diameter, so they will have the same radius also. For having same radius, that means we will have the same value of pi r square. That is, the area of both this wire will be same. Secondly, a load is applied on this wire. Since both the wire are connected end to end. So if we allow certain load to be hanged on the wire, then the same amount of load will be applied on both the wire. So we have the same value of force also. So this value of force will be same for both these wires. So we are not using both the force. This force per unit area, that is the value of stress, will be same for both this wire. So we can write this to be equal to this. So we can write force per unit area to be same as this. Now force per unit area, we can remodify this equation and we can write this was multiplied with this. So if we take this to in this side, left hand side, right hand side, then it will be divided by YC, that is Young modulus of copper wire. And now we are trying to place the value of Young modulus of steel wire and Young modulus of copper wire. So we can find out this value of Young modulus of steel and copper wire from this chart. So you can see here Young modulus of steel and copper from this video, from this page. Okay, it is already mentioned. So you can write this multiplied with the LC divided by LS. So this is the length of the copper wire and the length of the steel wire. So it is already given the length of the wire, copper wire, and the length of the steel wire. So we are placing this, and by calculating this we can obtain this value, and now we have found out to be 2.5. So force per unit area is equal to del of LC divided by del of LS, which we will find to be 2.5. So we have L of C is equal to 2.5 del L of S. Now it is given when these two wires are stressed by the load, the net elongation is found to be 0.70 millimeter. That is, if the wire is allowed to hold that load, then same amount, and then the elongation that is found is 0.70 millimeter. That is the change in length of the copper wire, and the change in length of the steel wire is 0.70 millimeter. So converting this into meter, we will get 7 into 10 to the power minus 4 meter. So these two wire will have same length. Now we have these two wire added up will give up to be 0.70 millimeter. So we have already found out the value of LC to be 2.5 LS. So if we place this value here, we will find 3.5 L of S is equal to 3.5 means 2.5 LS plus 1 del LS, that will find 3.5 del L of S, or we can find del L of S to be equal to 2 into 10 to the power minus 4 meter. Now we can obtain the force to be area multiplied with Y of C multiplied with del L of C divided by L of C, or the area we will obtain pi r square, that is diameters. The diameter is 3 millimeters, so we will get radius to be 1.5 millimeter. So pi r square divide into del L of C, and L of C we have obtained. So multiplying this, we will get 176 Newton. Next we have this problem of human pyramid. So you can see this diagram. Now total mass of all the performers is given to be 280 kg, and mass of the performer who is performing this is 60 kg. Now he is lifting certain weight. As you can see from this figure, this person is lifting this amount of weight. So the total mass of all these persons are 280 kg. Now mass of this person who is lifting them is 60 kg. So mass that is supported by the leg of the performer will be 220 kg. Now weight of this supported mass is, so the mass is 220 kg and the weight of the supported person will be 220 multiplied with 9.8, that is force is equal to mg. So we will get this value. Now weight supported by each thigh bone, since this person is holding with two legs, so one of the thigh bone will get the force of 1078 Newton. So by using the Young's modulus from the table, we have the Young modulus for bone. From this table you can obtain 9.1. So you have found out 9.4 into 10 to the power 9, and the length of each thigh bone is given to be 0.5 meter, 50 centimeter it is given, so it is 0.55. And now the radius of the thigh bone is given to be 2 centimeter, so it will be 0.02 centimeter, that is 2 into 10 to the power minus 2. So the area can be obtained by pi r square. So this is the area radius, it is given, so you can multiply, or del L you can find out easily by using this formula. And now you can apply this and obtain the value of the del L. Next we are trying to do the example 9.4. Here the question is having the square lead slab of 50 centimeter and thickness 10 centimeter is subjected to a shearing force of 9 into 10 to the power 4 Newton. The lower edge is reverted to the floor. How much will the upper edge be displaced? For doing this, we need to first find out the area. Area is given by 50 centimeter multiplied with 10 centimeter. We need to convert 50 centimeter into meter, that will be 0.5 meter multiplied with 0.1 meter. So this will give 0.05 meter square. This is the area that we have obtained. Now we need to find out force. So force is given 9 into 10 to the power 4. So we can find out the stress. Stress is equal to force per unit area. So stress is force per unit area. So force is given, area is given, so you can find out the stress. Now strain will be del x by del L, will be stress by G. We have G is equal to shearing stress divided by shearing strain, or we can write this strain will be equal to shearing strain will be equal to shearing stress divided by G. So we need to find out the value of del x by del x, so L will be multiplied with this. So if we multiply L with this, we can obtain 0.16 millimeter. Next we have the average depth of Indian Ocean is 3000 meter. Calculate the fractional compression del V by V of water at the bottom of the ocean. Given the bulk modulus of water is 2.2 into 10 to the power 9 Newton per meter square. So the pressure exerted will be S rho G, and S will be equal to the height, that is the depth, that is 3000 meter. Rho will be the density of water, that is 1000 kg per meter cube. G we have the value of 10, that is the acceleration due to gravity. So we can find out the value of P, that is the pressure that is exerted. Now we need to find out the fractional compression, that is del V by V. So del V by V will be equal to stress divided by B. So the stress is found out to be 3 into 10 to the power 7. This is the pressure or the force per unit area. Pressure also has the value force per unit area. Similarly, stress also has the value force per unit area. So we have found out this to be this value divided by B, that is the bulk modulus in case of bulk modulus of water. So it is 2.2 into 10 to the power 9. So dividing this, we will get this value. And thank you for watching, and please do subscribe to my YouTube channel. I will try to provide all the solved example of the NCERT. Thank you.